So in complex high-frequency calls of carnivores, why it is not possible to find formant frequencies? Someone would say that we cannot use tract when we have a very tonal call. You have the fundamental frequency, harmonics there, and they are really a fine line. Tract would be better to investigate noisy sounds, not harmonic sounds. So when you have an harmonic call, how to find formants?
If the harmonics are very separated and the formants are in between two harmonics, for instance, it's almost impossible to detect where the formant is. Of course, if you add some noise, we can at least have some ideas where the formants could be. But it's not simple for spectral analysis to detect formants where, in the case where harmonics are very well separated. If a child has a F0 of 600 Hertz and formants between 600 and 200 Hertz, it's very difficult to find where it is without some filtering. We can filter the sound in order to eliminate some part of the noise or maintaining the harmonics and try to figure out where formants and harmonics are. But it's tricky, it's not very simple. To study baby cries and cries is useless because there are no formants. The formants are not everything. You can use the whole spectrum and extract information from this spectrum. Center of gravity, standard deviation, asymmetry, every kind of information differentiates baby cries. When an individual is doing things like that, because the tract, the vocal and the nasal tract are different, we can differentiate individuals from the spectrum of this inhalation. For instance, you can recognize a friend just by coughing. When they cough, okay, is this person coughing? It's the same for baby cries. Computing things from respiratory signals. We can infer vocal tract length from different kinds of vocalizations. It's not simple to find at first, but we can infer vocal tract length. We have data on vocal tract length from some animals. We can infer the size of the head of a capybara, the size of the head of an elephant, of a rodent. And from that, we can infer formant position. But I don't know the vocal tract length of this person that I illustrate to at the beginning, and I can compute formants. The number of formants for speech at least, for every 1,000 Hertz you have one formant for the first guess. But you can adapt by seeing in the spectrogram the number of gray, black areas from 0 to the maximum formant. Of course, for formants you can use LPC or capture analysis, but you can change the number of formants and by comparing with the spectrogram and see if the choice was correct or not.
And then according to the formula that you can find in some papers, you can see where the frequencies of the formants should fall according to this length of the vocal tract. So that's the first thing I do. I check where they are supposed to fall, and it's going to differ obviously because the formula assumes a straight tube closed at one end and open at the other, which is not actually correct because it's never a straight tube, but it gives you at least an approximation. And then you can ask Pratt, for example, if you use Pratt, to find the number of formants you expect. So if on pigs, according to the length of their head, I expect 3 formants below 500, I think, or 550 or so, then I ask that, and then Pratt will probably highlight these 3 formants. So the formants are a bit tricky to start with because you need to know what to expect. At least the first time you measure formants in a species or in a specific breed or age, you need to know the length, the approximate length of the vocal tract. Goats and pigs is to measure the distance from the nose. This gives you an approximation, knowing that in reality the vocal tract is a bit longer because it goes up and down, but it at least gives you a range of what to expect. Really depends on whether it's an open mouth or closed mouth called, so you have to be careful with that on the pigs. When they open their mouth, you get an extra formant here that is being filtered when they close the mouth. We don't know if it's real formant 1 and 2 and 3. Maybe there is formant 2 is actually here. Just to be consistent, I always call 2 and 1 and 2 and 3 and measure them in all individuals in the same way. You have to compare across different animals and different times to make sure that is always what you see. So you always see one line around here and one line around here and one line around here. And you can measure them, and then you can also reverse back to see what you found. Does it correspond to the vocal tract length you expected? So you know how many to find, you ask Pratt to find them, and then after you measure them, you can also double check that this corresponds to the length expected in this specific animal. So if they are high pitch, you don't have close harmonics, so you won't even see the formants, so you won't be able to measure them. So it might not be useful. For example, let's see in chicken, you only have 2 lines. There is no pixel if you want to see the formants. And you don't see the formants, then Pratt also won't be able to measure them, so you won't be able to do anything good. So I wouldn't consider measuring formants. So that's one thing to consider. Are they high pitch or low pitch? And only go for formants if they are low pitch. But they might be high pitch and chaotic, then you'll also be able to see the formants. And you can get an information about the length of the head, then you can try. But if you don't see anything yourself, you probably won't be able to find it either. Yeah, I was very enthusiastic about formants, especially when we look at emotions, but overall it very often correlates to the energy quartiles, for example. The information that is in the formant, you can have it somewhere else. You can have it in much easier measures.